Hello class, I'm working out of your Pre-Algebra book 4.6, Geometric Sequences. We'll work number 16 shortly from your actual assignment. If you were in class, you'd have a few notes. Geometric sequence is defined by numerical terms that differ by multiplication of the value r. So in the arithmetic sequences we added last section, geometric sequences are multiplied. R is the common ratio, so it's the multiplier. What are we multiplying each term by to get to the next term? And then recursive formula. Recursive has a root word of recurring, so that means repeating. So grab these notes, pause the video to jot them down, whatever you need to do. So in an example, we're given a label of a subscript 1 and a value for that label. It's just saying that a subscript 1 is the first term in a sequence, and it's a label for that value. So a subscript 1 is a label for some term in your sequence. The r value is the multiplier. It's also called the common ratio. If you're given that information, you know what to multiply each term by to create the geometric sequence. So we have a subscript 1, the first term given. We have a value for that to get started. It is 1, excuse me. And then a subscript 2 is the preceding term times the common ratio. So we have a subscript 1 times the ratio for a subscript 2, the next term, and that's going to be 1 times 3, so a subscript 2 will be 3. A subscript 3 is going to equal a subscript 2 times r, and that's where this formula comes in, where it's labeled like this, a n minus 1. It's just a fancy label for the preceding term that you're using, just like we're doing in the sequence. So a subscript 2 times r equals 3 times 3. That would be 9. A subscript 4 is a subscript 3 times r, and that is 9 times 3, which equals 27. And then a subscript 5 is a subscript 4 times r, which is 27 times 3. That becomes 81. So to jot down your terms in the sequence, that would be 1, 3, 9, 27, 81, and so on. That would go on infinitely. If you're actually asked to write the formula from a set of numbers given to you, then it would probably be called the recursive formula to show how that sequence repeats. And we'd have 729 for an example, 243, 81, 27, and so on. So a couple things need to happen here. You need to look this over and say, well, some kind of division is happening. Remember, fraction bar is a division symbol, and you're dividing when you use a fraction, so that is a possibility here, to multiply your sequence terms by a fraction, and that would become the common ratio or the multiplier. And use your divisibility rules. For instance, 7 plus 2 is 9, plus 9 is 18. So mental math that. Say, okay, it's not even, so this could be divided by 3 or 9, but probably to get to 243 from 729, I'm not dividing by 9. I would be more likely to divide by 3. So divisibility rules will help quite a lot here. And we can get around to my first term is 729, and my R term is probably 1/3. So if you have that information, you can write the recursive formula. Remember, A subscript n is just some term in your sequence. It's like a fancy label or a value that will show up in your sequence for this set of numbers. So A subscript n, some term in my sequence, is going to be R times the preceding term to get to the next term every single time in the sequence. So this is the formula from the given information. If you're given a sequence like this, we can see somehow it's being multiplied because the numbers are growing. And we can see right away to get from 3 to 6, it would be 3 times 2. So that's true from A1 equaling 3 and A2 equaling 3 times 2 equals 6. And then we have the next term is 12. Well, 6 times 2 is 12, but break that down further. Consider that to get to the next term, you'd have 3 times 2 times 2 equals 12. How many 2's are there? Remember, in divisible math, there's an exponent of 1 on every number. But for the next term, we could say A of 3 equals 3 times 2 to the second power to get to 12, and so on. A of 4 might equal 3 times 2 to the third power. Should we check that out over here? That would equal 24, to equal 24. And then A of 5 would equal 3 times 2 to the fourth power. Check that out over here. That equals 48. So that's true. And we could keep going in that sequence. So we would have a pattern emerging here. 1, 2, 3, 4 for the exponents of the ratio multiplier. So we would have a formula that would look like n equals 3 times 2, and then in our exponent, n minus 1. So A of 1 is our first term, and then our ratio multiplier that's multiplied by is 2 times the exponent of the preceding term. All right, number 16. In our actual assignment. So you're given a of 1 equals 2, and you're given a of some term in the sequence is equal to 4a of n minus 1. So it's some kind of formula. And if you're starting with a of 1 equals 2 and you apply this formula, you need to pull out the value 4 is your R, or common ratio multiplier. So, okay. So it tells you that in the formula. So we go grab that. And so if that's true, we have a of 1 equals 2. What's a of 2? We apply the formula. We're going to take 4 times a of 1, which will equal 4 times 2, and the next term equals 8. A of 3, we're going to take 4 times a of 2, which equals 4 times 8 for the a of subscript 2 value, which is going to equal 32. A of 4. 4 times a of 3, which equals 4 times 32. Doing some work in your margin, you're going to get that is equal to 128. And you're asked for 5 terms, I believe, so the 5th term, a of 5, will be 4 times a of 4, which equals 4 times 128. Do some work in your margin, and you're going to get that's equal to 512. So you have your first 5 terms from the given formula. Write those in a sequence order. You're going to have 2, 8, 32, 128, and 512. All right, I hope this helps, and I'll see you soon.